Can space mining disrupt Earth's tectonic activity is a debate that raises geological, astrophysical, and environmental concerns about the potential consequences of large-scale space resource extraction. Space mining refers to the extraction of valuable metals, minerals, and water from asteroids, the Moon, and other celestial bodies to support Earth's industries or space colonization. Proponents argue that space mining could reduce the strain on Earth's natural resources, decreasing the need for destructive mining practices on our own planet. However, some scientists speculate that extracting large amounts of material from space and bringing it to Earth could alter the planet's mass distribution, potentially affecting tectonic activity. Earth's tectonic processes are driven by mantle convection, gravitational forces, and the movement of its lithospheric plates, making any disruption to mass balance a possible concern. One theory suggests that adding mass from space mining could increase pressure on certain tectonic boundaries, potentially influencing earthquake activity in geologically sensitive regions. However, others argue that the mass of material brought from space would be negligible compared to Earth's total mass, making tectonic disruption highly unlikely. To cause significant changes in Earth's internal dynamics, space mining operations would need to transport massive quantities, billions of tons, over an extended period. A major consideration is how extracted material would be distributed on Earth, as concentrated deposits in certain areas could create localized pressure changes in the crust. Some researchers compare this scenario to glacial melt redistribution, which has been linked to increased seismic activity due to shifts in weight on Earth's crust. Studies have shown that glacial retreat and sea level rise have slightly altered Earth's crustal stress, leading to minor changes in earthquake frequency in some regions. If space mine material were deposited unevenly, it could exert pressure on faults or subduction zones, potentially accelerating stress accumulation. On the other hand, space mining could reduce the need for terrestrial mining operations, which are known to cause localized seismic activity due to deep Earth excavation. Industries such as coal, lithium, and rare earth metal mining have been linked to man-made earthquakes, raising the possibility that space mining could help mitigate these risks. Some scientists believe that instead of causing tectonic instability, space mining could be a solution to resource-driven environmental destruction, preserving Earth's ecosystems. One concern is that removing large amounts of material from celestial bodies, such as asteroids or the Moon, could affect their gravitational relationships with Earth. The Moon's gravitational pull influences ocean tides, tectonic stress, and even the length of Earth's day, meaning that altering its mass could have subtle but significant effects. If space mining companies extract vast amounts of material from the Moon, some geophysicists suggest it could shift the Moon's center of mass, affecting its orbit. A change in the Moon's orbit could, in theory, lead to slight variations in tidal forces, which influence Earth's tectonic stress and volcanic activity over long periods. Asteroid mining presents a different concern, as redirecting large space rocks for resource extraction could alter gravitational interactions within the solar system. Some researchers fear that interfering with the asteroid belt could result in unexpected orbital shifts, increasing the risk of asteroid impacts on Earth. If asteroid mining removes mass unevenly, It could create unstable debris fields, potentially sending smaller fragments toward Earth and increasing collision risks. Others argue that asteroid mining could be used strategically for planetary defense, allowing scientists to redirect dangerous asteroids away from Earth. NASA and private companies like SpaceX and Blue Origin are already investing in asteroid prospecting and lunar mining technology, making space mining a near-future reality. Some planetary scientists suggest that space mine material should be used primarily for off-world construction, reducing the impact on Earth's mass balance. Future lunar bases and space stations could use extraterrestrial materials for infrastructure, minimizing the need to transport large amounts of resources back to Earth. Another approach is to process mine materials in space, using them for fuel production, spacecraft manufacturing, or asteroid-based industries. If space mining becomes a large-scale industry, governments may need to establish international treaties to regulate mass transport and mitigate unintended planetary effects. Regulations could limit how much material can be brought to Earth annually, ensuring that planetary mass redistribution remains within safe parameters. Some critics argue that the biggest risk of space mining is not tectonic disruption, but economic and geopolitical conflicts over resource control in space. If certain countries or corporations gain monopolies over asteroid mining, it could lead to economic disparities and potential conflicts over space territory. The Outer Space Treaty currently states that no nation can claim ownership over celestial bodies, but this may become contested as space mining expands. The environmental impact of space mining also raises concerns about potential contamination, as introducing extraterrestrial materials to Earth's biosphere could have unforeseen consequences. Some scientists propose studying the long-term effects of mass redistribution before launching large-scale space mining operations, ensuring that planetary systems remain stable. Technological advancements in artificial gravity and orbital balancing may help offset any potential mass shifts caused by mining and material transport. While the risks of tectonic disruption remain largely theoretical, continued research into Earth's geophysical responses to mass changes will be essential. NASA, ESA, and private space companies are developing computer models to simulate the potential consequences of large-scale space mining on planetary balance. A major unanswered question is whether removing vast amounts of material from celestial bodies could lead to unintended cosmic chain reactions, affecting orbits or planetary systems. Ultimately, the debate is not just about whether space mining could disrupt Earth's tectonic activity, but whether human expansion into space can be done responsibly and sustainably. The real question is whether governments, scientists, and corporations will develop space mining technology with long-term planetary stability in mind, or if unchecked exploitation will introduce new risks to Earth's delicate geophysical systems.